What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it. We are the day before the SAT and we're doing that good old fashioned review. But it's a little different because you might notice a different setup. And I'm broadcasting from Mexico here for a win. Scalar Learning channel. Uh-oh. My audio's a little funky. Why is the audio funky? Hold on, I'm checking the audio. It sounds weird, huh? It sounds echoey. Hold on. I wonder why. Why does it sound Oh, I know why. We go blop. Okay, wait. Now it should be better. Hold on. Hold on. So I'm going to keep testing it. I think it's going to be good in 1 second. Hold on. Let's see. Did I fix? Yes. All right. We fixed it. Okay, so just a heads up, I'm doing everything from my laptop. Normally I always do it from my desktop, so it's a little strange. Anyways, let's get down to business. Thank you guys for coming. First of all, it's so excited to see everybody. And if you could give this video a like, just in good faith, just knowing that I'm going to give you good content, that'd be amazing. Good prep for tomorrow. I'd really appreciate it. If you got questions or comments, please put them in here. I'm going to read through some of these, and then we're going to start hitting it as we should. Yeah, the man is finally here. I'm so sorry. Let me tell you the rundown of what happened. My flight was delayed an hour and a half, but I still had enough time to get to the hotel, enough to set up and everything, but it just wasn't as I planned. But I still made it. And then I had to download OBS, get everything set up, blah, 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 and get the presentation ready to go. But we're here. We're ready to go. We're ready to rock. And that's it. I got my little mobile setup, and I think everything is looking good. So let's just hope this Wi-Fi is nice and solid as we proceed. Okay, let me just see what we got here. We got a couple of questions and comments. Feeling confident. Good. 700 plus for C. Good luck on that. Wish you the best of luck. Good luck, soldiers. Exactly. And we're going to be doing a couple of predictions for the digital this time as well. But just a caveat, I'm doing my best with the digital with the limited information we have. So, just take that with a grain of salt. Hey, Qatar. I've been to Qatar. It's so amazing. Qatar is such a cool place. Good luck to you guys. Awesome. Okay, yo, watching the Qatar F1. Ooh, that would be amazing to see F1 there. Okay, without further ado, let's get into this. And we're going to start with a section, all right, that was really popular last review session. And that was oops, sorry. Oh boy, what am I doing here? That was the prediction section. So we're going to start with the predictions. And after that, we're going to hit some predictions for the digital, and then we're going to talk about formulas and important things, and we're going to take some questions and do all that. So let's get into the predictions. Now, here's the thing, right? I think that the predictions that I made last time were based on the most recent SATs in the last couple of years. And, we haven't gotten the August SAT. That's not released. So I don't have any additional information. Hold on 1 second. I don't have any additional information, right, since the last prediction. So I'm still going to go through these similar predictions. We're just going to talk about them a little bit more. But it was pretty cool that apparently a lot of these were right. That's what people told me anyway. So we're going to do something similar once again. All right, let's get into this. So first we're going to start with the US SAT. And we're going to jump right in. And the first prediction of type of questions I've been seeing a lot in the last few years is systems of inequality. And guys, let me know if there's any issues with the streaming or the audio, but I think so far it's good. I paid for the high speed. Anyways, so these types of equations I'm seeing a lot of, and here's the dealio, right? This is what I say. When we're talking about systems of inequalities, I don't mess around with any algebra. I don't do too much. I just straight plug and chug. So you see something like this. I see 1, 1. Does it work? Plug in 1. Is 1 greater than 4? No. Out. -2. Is -2 greater than -8? Yes. Is -2 less than +2? Boom. It works, right? So B would be the winner. Trial and error, plug and chug, system of inequalities. That is the strategy. Same thing with this one, okay? You know, you've got this system, and I'm going down the line, plugging and chugging. This is just a little bit of a longer, more difficult one because you got to plug in 3 sets into each of these. It takes a while, but that's how you do it. Now, if it's calculator, you can graph the inequalities, and that might help, but that's what I would say. Number 2, quadratic formula questions, and in particular, these ones that are the kind of funky ones where it doesn't say use the quadratic formula. It says, hey, we're trying to get these solutions. It's in this format. We need this particular value. Well, what is that reminiscent of? Quadratic formula, right? With that n plus or minus square root of something. But you might be like, well, it's supposed to be over 2a, all this stuff. Well, the assumption is or should be that something is canceled out. So you still just go back to the basics. This kind of reminds you of quadratic formula. Use the quadratic formula. Because remember, quadratic formula works for every quadratic regardless of anything to solve it, right? So that's that. Okay, here's another example. Same idea, right? And this one keeps a 2 in the bottom. So you just do your same thing. Negative b plus or minus square root of b squared. Oh, I just posted a video on this, by the way. Let me show you. Check this out. See if we can get into my channel, my shorts. Look at this. Posted it last night. If you're trying to memorize this and you're having trouble, watch. Yeah. All right. So anybody who's struggling with this, let me pop this in the chat. And I don't know. Some of my students say it's cringy, but hey, it works. That's all I gotta say. Oh, by the way, let me post this in Discord as well, so people know we're going live right now. If you haven't joined our Discord community yet, I would highly recommend it. It's totally free, totally awesome. You can collaborate with tons of people. I'm not really super active on there. I'll jump in occasionally like this to spread the word and post stuff. So if you want to be in the know for when I'm streaming and all that stuff, that is the place to be. Live now. Boom. Okay. So just let the crew there know that if they want to pop on, they can jump on. All right. So moving on, another quadratic formula one, right? Same idea. See, I mean, I've seen so many of these, and this is from the last couple of years, so it's pretty crazy. So be on the lookout. Quadratic formula, simplify, find the constant, find whatever's left in the square root. Oh, yeah, another one. Look at this. So many. So crazy. I forgot how many I put in here, how many I found. So it's quite a bit, but it's the same dealio for all of these. Okay. All right, this is big time because it's not only big time actually on the, hold on one sec. I've been up all night, so I got this coffee especially for the stream because I'm exhausted and my voice is dying. But anyways, geometric proofs, right? These have been popping up more and more and more. So this is a big thing for sure to be on the lookout for. So, an example, hey, which of the following is sufficient to prove that these triangles are congruent? So, know your congruent triangle theorems. We're going to go over those in a bit. Side, 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 angle, side, angle, side, angle, side, hypotenuse, leg, and angle, angle, side. Those are the 5. So what they're giving you here is they're telling you 2 angles, really 3 angles are congruent. When they know 2, it's really all 3 have to be. So what do we need? We just need one side, and we need one side pair of corresponding sides, okay? So this angle doesn't help. One side doesn't help. But hey, BC and EF corresponding sides because they're both opposite congruent angles, which I believe is 97. So they're both opposite in the 97 degrees. That's what makes them corresponding. They're congruent. We got them. Boom, done. Here's another example, right? They got a right triangle, AC. By the way, for these ones, make sure to draw your triangle out. I always say it, but if you're in a geometric problem, make sure to draw it out. And we got all this stuff. So we got AC is 12, A is 40, B is a right angle, which is line can be determined from the given. Okay, so this is more just like, hey, what can we figure out? Well, here's the dealio. I got 2 angles, which means I really have 3 angles, right? B is 90, A is 40, C would have to be 50. Adds up to 180, right? So, of course, I know measure C. But the question is, can I get measure side AB? Now, this is a little tricky because you might be like, well, I can't really use Pythagorean's theorem, blah, blah, blah. But what you can use, and what we do have to know on the SAT, is trigonometry. So the fact that we can use trig to get AB, and I think you would use, well, whatever it would be when you draw it out, involving AC, which I believe is a hypotenuse. You could use sine or cosine, depending on which angle you choose. Boom, you can get it. So that's an important one. And this one as well. Same thing. Angle, angle. So we know all three angles. So all we need is a corresponding side. Now, this is an interesting one, right? Because they give two where they give you two equal sides. But notice the issue with, which one? It's with C. C, they're given this side is equal to this side. Well, those aren't corresponding sides. Why? Because they're not opposite the same angles. But for B, BC, and EF, yeah, that's cool. They're both opposite 35. We're good to go. Okay, and then here's another example, right? This one leverages a slightly different rule. We're going into similar, okay? So the rules for similarity: angle, angle, side, 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 meaning all three sides are proportionate, and then side, angle, side, okay? And again, side, angle, side doesn't mean the sides are equal. It means two sets of sides are proportionate and the angle in between those are equal. Okay, but anyways, when you say that these two are parallel, this is all we need, because that then shows that that angle is equal to that angle, alternate interior angles, same with that and that. We already have vertical angles, but that's an angle, angle. The 1/3 thing is cool because it shows a proportionate relationship, but that's only one side. And there's no, we need two sides, side, angle, side. So here's another example, okay, of something that I could definitely I'm pretty sure will show up tomorrow. Is not sufficient. Look at that little curveball, right? Now I already have vertical angles. If we know that these two are parallel, we got all these other alternate interior blah, blah, blah angles. So A is sufficient. D is equal to B. Nope, that is sufficient. Angle, angle. We talked about that. Oops, sorry. AB is equal to the length of DE. That one is not sufficient because we'd only have one angle in one side, so it's going to be C. And then A is equal to B. Yeah, well, obviously that's the same as like the parallel one, so that is sufficient. This is another one I've been seeing occasionally. Not as red hot as some of the previous ones I've shown you, but yeah, know your prisms, okay? And all you got to do is calculate the area of the face that is kind of extended back. This is a triangular prism. So you calculate the area of that triangle and multiply it by the height, or this distance that it's extended, okay? Percent increase, here we go. Now this is a semantic issue, okay? I just did this on the digital SAT yesterday. It said, hey, this thing is, I don't know what it was. It was like 200% of something. When they say 200% of something, it's literally, you're taking 200% of it, and that's the answer. When they say a 200% increase, okay, you're calculating 200% of this, which is 600, and you're adding it to the original. You're adding it to 300, giving you 900. So it's important difference. All right, these are kind of new. And I'm sure you learned them in Algebra 2, but the bottom line is what you got to know is that the asymptote, this invisible like barrier, is going to be where the denominator zeroes out. In this case, at -1. Boom, x equals -1. This would be wrong, x equals 1. This one might work over here. And this one's wrong too. So it's either A or C, and then just do a little good old-fashioned plug and chug, right? It says K is a positive constant. Let's make it 2. I don't know. And that's it. And then you can kind of see which ones make sense. So if, let's see, which one is correct here? As x is, if it's 2, yeah, I think it's, I think it would be C. Hold on, let me just think for a second. If it's 2 minus x, and then we're getting close to -1, 2 minus negative, so it's 3 over something. Oh no, actually I think it's A, because it would be going towards positive infinity as x gets closer to -1 if k is positive, right? So because then that would be -1. That'd be like 3 over point something something. Yeah, I think it's A. But anyways, you can check like that. You can choose a value for K like I did, like 2, and then kind of plug in some answers and just see, what's what. And then to the left of -1, it looks like we got all negative values. Like, you can imagine if X is -2, 2 minus -2 is 4, over -1 is -4. That kind of checks out. So here's another example, another rational function. Again, these have been popping up more frequently. Again, we should have an asymptote at -2. And we should have a 0, by the way, meaning an x-intercept when x equals 4. 0's out the numerator. That's another important thing. What is that? 4? Maybe it's B. Oh, no, it's the wrong asymptote. 4 and an asymptote at -2. It looks like this. It looks like that has the right asymptote at 4. And then we got a invisible asymptote at x equals -2. Let me just plug in a couple points here. Let's plug in 10. -40, that would be -24 over 12 is -2. Yeah, that felt right. So anyways, always confirm with a couple points. If I'm getting stuff wrong at any point, I apologize in advance. I'm like so tired right now, but I think I'm doing okay. All right, the unit circle. This is interesting. So I used to always say, hey, you don't need to know the unit circle. Like, you can use it if you know it, but don't stress out about it. But I hadn't seen many questions like this. This is just a straight up unit circle question. Now you can still figure it out without the unit circle. You can be like, oh, what's the reference angle? Pi fourths. Okay. Take sine of pi fourths, that's like sine of 45, special right triangle, boom, 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 right? And you can still get it. But if you know the unit circle, it's a little easier, right? And it tells you, fine, sine is positive in the second quadrant. That's what this is. So it's one of the positive options. And, the fourths are always rad 2 over 2, some variation of that. So it's C. Okay, slopes of radii and tangents. This is an interesting one. So one thing to remember is that a line that is tangent to a circle is perp to the radius that touches that tangent. So when they say, hey, line T is tangent to the circle, be like, well, darn it, man, I wish I could know the slope of T. Well, we can figure out the slope of T. And then that's how we can get the equation of the line. Because you get the center and this point here. What's the slope of that? It's going down 4 over 5. So that's -4/5. So the slope of this is +5/4. Opposite reciprocal, which we're going to go over in a second as well. Dude, my voice. I'm so tired. I didn't get enough sleep because I didn't really get any sleep. Okay. All right, line K is tangent to the circle with center C at the point A shown. What is the slope of line K? Oh, yeah, same thing. Find the slope of the radii, and it's perpendicular. Okay. Number 9, exponential graphs. We do see a lot of this, but it's just this interesting variation. They didn't say this is the graph of f of x. Look, they said this is the graph of f of x minus 1. How sneaky, right? Because f of x then would not, this is shifted down 1. F of x would be shifted up here, right? Which means it has a y-intercept of 3. Which one of these has a y-intercept of 3? Plug in 0, and it would be D. Right? 2 to the 0th is 1, plus 2 is 3, boom, done. Last but not least, sum of solutions. Of course, we've seen this before. I always say this is an important formula. But look at this. Nice and easy. I've been seeing a lot of these. Sum of the solutions, -b over a. 1, +1 over 1. Boom. C is the winner. Done. Okay. Now I'm going to point out a couple of questions that I flagged from the digital SAT that felt interesting, that felt a little bit on the unique side to the digital, which is why I wanted to point them out, because it could be an indication that these could show up. Again, take this with a grain of salt because we just don't have that much information about the digital outside of what's been released. Okay. So I thought this little circle transformation one was interesting. So we're shifting this down 2 units in the plane, right? So when you shift down, right now this has a, oh wait, hold on. Represent circle A. Circle B is shifting down. Yeah. So right now this has a center at 0, 1 because it's the opposite. So we want a center at 0, -1. So what I'm looking for is the x to be the same, which is true in B and D. But then we should be doing +1 instead of plus minus 1. Now the minus 3 makes sense. So like, wait a minute, I'm minusing 2, I'm shifting it down, right? But it's actually not the case. And this is from the digital, so just graph them. See which one's a downward shift to 2, right? Okay. This one I did see pop up a bunch on the practice test. So again, it's just going back to when they talk about the nature of the solutions, nature of the roots, we're talking about discriminant. So if it's one solution, take the discriminant, b squared minus 4ac, set it equal to 0, boom, done. And these interesting ones, I don't know what it is on the digital. I've just been seeing a bunch of these cube ones, right? Cube has an edge length of 41. What is the volume? I mean, this one's pretty straightforward. Volume formula, right? 41 times 41 times 41, whatever that is. It's probably D. But anyways, you know, and then I've seen some other ones where they're talking about cubes. I don't know. It stood out to me. I wanted to flag it. This might be my prediction. Some sort of rectangular prism or a cube problem is what I would say. Okay. All right, now we're getting into the formulas portion. So before we jump in there, let me just look at the comments. The graph questions. Well, the graph questions, actually, there's a nice little hack for them because remember, you can plug in points. You can check values. Thank you guys for all the likes, by the way. I really appreciate that. You know, there's a lot to do, and there's a lot of things you can verify with those. Oh, amazing on that 120-point increase. Good for you, Maria. That's fantastic. Yeah, that does depend on the school. For scholarships of 12, for a score of 1200, I mean, like, I made a video called Everything You Need to Know About the SAT that talks about scholarships at different schools. Okay, let's get back to it. Excuse me. All right, you guys have probably seen this video. Or well, I shouldn't assume that. Maybe you haven't. So let me post it here. So here's the video if you guys want to go over it later. I do like to talk about these formulas. You know what I'm going to do, actually? I'm going to tell you guys, if you haven't seen this, to watch it. Instead, I'm going to go over some important ones, okay? And we don't have to do the whole thing. We'll kind of hit spot check and do the critical ones. And then if you guys have questions about particular ones, we can go back. Slope of the line, I think pretty much most people know this one pretty well. Again, check the video if you want to see me go over it in more detail. And same thing with slope intercept form. This is a classic, okay? Right? Point slope. This one's really important. Right? It's really easy if you do have a coordinate. Like, hey, if I look at this, I know I have a coordinate at 3, 4, and I have a slope of 3 over 2. Okay, and you can go backwards. You can take a coordinate and the slope and put it together that way. Excuse me. Okay, midpoint formula, just taking the average of the different coordinates. Distance formula, not as essential or critical, but it comes more in handy when you're like, hey, what's the length of the radius? What's the length of a diameter of a circle? Stuff like that. All right. Length of an arc. You'll recognize this one because it's just circumference, but then times the fraction of the central angle over the total amount of degrees, 360. Boom, done. Area of a sector, same thing. Area of a circle, pi r squared times that same fraction. That's it. Quadratic formula we talked about, sent you the song, so that's legend. SOHCAHTOA, very important, right? Just remember. Oh, I got a song on this too. Hold on. Okay, so check those out if you haven't yet. Those songs are pretty helpful if you don't know those formulas, you know. And this is all sine of A, right? Opposite over hypotenuse, etc., etc. Okay. Probability, I think you're familiar. Again, watch the video if you need to. Circle equation. This is an important one. Like I said, I keep seeing it on the digital, the real. It's everywhere. You got to know it. The center is hk, so in this case it would be 2, -5. And the radius would be 6, square root of 36. Okay. Exponential growth. We've talked about this, right? Initial value, growth rate in decimal format, and that's the time. So this would be growth, right? That's an example there. And that would be decay. And notice it's 1 plus the percent growth rate, 1 minus the percent decay rate. Boom, done. Vertex of a parabola, very, very, very important formula, -b over 2a. That's it. So if you ever get the vertex or need the vertex and you're in standard form, you get that. That gives you the x value. Plug it in, you get the y value. Boom, you got your vertex. Vertex form is just like this, where you can see the vertex, h, k. That's it. Pythagorean theorem is actually given in the formula sheet, but I like to include it just because it's so darn important for right triangles, you know. Simple, but really useful. Distance equals rate times time. So I would highly recommend using this if it is a rates problem where this is applicable. This is a relationship such that sine is always equal to cosine. Sine of an angle is equal to cosine of the complement. So if they're like, hey, we know what sine of x is, what's cosine of 90 minus x? Oh, it's the same thing. Okay, they love to test that one. Sum of solutions we've already talked about. It's -b over a, which is an important one. I think the digital will sometimes test the product. What is it? Hold on. Product of solutions of a quadratic. I think it's c over a or something. Yeah, it's c over a. So the product, I think, might show up on the digital SAT. So that formula is c over a. Again, if you forget the formula, just calculate the two things and multiply them. You know, calculate the two solutions. No problem. Okay. Discriminant, as I mentioned, b squared minus 4ac when it's in standard form. When it is less than 0, no real solutions. Equal to 0, 1. And greater than 0, 2 real solutions. This one's not as important. It's a little bonus, icing on the cake if you can memorize it. But you can also just make it into a special right triangle. Draw a height, an altitude, make it a 30, 60, 90, etc. This is just really useful. If you remember 3, 4, 5 mostly and its multiples, that shows up a ton on the SAT. So you can use Pythagorean theorem if you forget it, but you'd be like, oh, 3, 4, 5, easy, save some time, boom. All right, perpendicular slope. If slope is a over b, perpendicular would be -b over a. Also, parallel slopes are the exact same. Another thing that's important to remember. So if the slope is 2/3, I want the perpendicular slope, -3 over 2. Boom, done. And sum of angles in a polygon. Again, not as critical. It's not tested as much. But, you know, you plug and chug. For a triangle, that's the one you got to know, 180. For this one, use the formula. Oh, 360. For a pentagon, oh, 540, right? Plug and chug. Okay, that's it for the formulas. And those formulas are really important. I would highly recommend you make sure you know all of those. Goated on. Thank you, Con. Okay, guys. That's kind of what I wanted to show you guys. And I think I might have to tap out because I am dead. I am beat. And I hope this week was useful for everybody. I hope you felt it was beneficial. If you did find it useful and you did find all the stuff helpful, again, likes, engagement, all that stuff would be super helpful if you could give this video a like. I see 28 likes so far. That's pretty good, but I'd love to see more. If you could swing it, that'd be amazing. And that's it. All I want to tell you guys is tomorrow, whether you're taking digital, whether you're taking the US version, whatever, I wish you the best of luck, and I wish you, lean on your preparation. If you're feeling nervous, you're feeling anxious, a little bit of nerves, a little bit of anxiety is actually a good thing, I think. Keeps you on your toes, keeps you ready. And so don't run away from that, but trust in your training. Just like if you're going into a athletic competition or whatnot, trust in your training. Get some good sleep, get up early, eat healthy, do your thing. You know what to do, and knock it out. And let me know how it goes. Hit me up. Leave a comment on this video tomorrow. I'd love to hear how you guys did, and we'll do a follow-up later on, maybe next week. That's it, guys. That's it from me, live from Guadalajara. I gotta sign off. I'm dying. I need to take a nap. I need to get some sleep. Thank you guys so much for joining. This was a blast to do it on the road. So got my travel mic. I think it was pretty fun. I think it was a success. And that's that. All right, guys. Best of luck, and I will see you in the next video. Take it easy.